Welcome to Maths with EJD. We are talking about Laplace transform, and um, our focus is on inverse Laplace transform. So, starting from this video, I'll be looking at methods for inverse Laplace. I introduced this in the last video. The first method would be the partial fraction decomposition method. Partial fraction decomposition. Then there is convolution theorem. And of course, we have the residue theorem. So in this video, I'll start with the partial fraction decomposition method. Partial fraction decomposition. Okay. So talking about partial fraction decomposition, of course, before now we've talked a lot about partial fractions, especially under basic calculus, because they are before you integrate certain functions, you have to resolve them into partial fractions for easier integration. So for this now, the concept is as follows. When f of s, s is the frequency domain. The whole idea of Laplace transform is to transform something in the time domain into the frequency domain, the time domain to frequency domain s. So now inverse Laplace is now to take it back from the frequency domain s to the time domain t, so to speak. So when f of s is a rational function is simply a function that is expressed as a fraction of two other functions, so to speak. So when f of s is a rational function, is a when f of s is a rational function, right? Particularly a fraction where the degree of the numerator is less than that of the denominator. That is, the degree of what you have at the top is less than that at the bottom. So we can talk about partial fraction decomposition. Partial fraction decomposition is an essential technique. All right. This method breaks down the function into simpler individual terms, each of which corresponds to an easily recognizable inverse Laplace transform. Inverse Laplace transform. So let's look at steps. What are the steps involved in using for partial fraction decomposition? The first thing is to factor the denominator. Factor the denominator of the rational function. if possible. In some cases, they are already factored, so you just go ahead to the next step, and the next step is to express the rational function as a sum of simpler fractions. So these simpler fractions are called the partial fractions. So, but the complex one is what you can call the compound fraction. So it's more like you're resolving compound fractions into simpler fractions. And step three is to solve for the constants. So you solve for the constants in these simpler fractions. So step two is nuanced in the sense that the way you are going to express the fraction is dependent on the nature of the denominator. Okay, I mean I get to that in some depth, so you can check integration by partial fraction, by resolution into partial fraction under basic calculus. So take the inverse Laplace. That's the last step always. Take inverse the inverse Laplace transform of each term individually. Okay. So with this, can we go for an example? Okay. Example. Given f of s equals 2s plus 3 all over s plus 1 into s plus 2. So you can see the denominator here is already factored. Find the inverse Laplace transform. Okay, so let's go for that. Solution. So the first thing is to factor the denominator. So we have f of s equals 2s plus 3 all over s plus 1 into s plus 2. So it's already factored, so we don't worry. So if it wasn't factored, we would have had something like s squared plus 3s plus 2. But now we have it already factored, so no worries. So this is the first thing we do. The second thing we do is to decompose. The second thing is to decompose into partial fractions. So it means you have 2s plus 3 all over s plus 1 into s plus 2. And that is similar to, because this is linear and this is linear, so we have a over s plus 1 plus b all over s plus 2. So our job at the end of the day is to find a and b. So with this now, we need to look for a and b. And the first thing we want to do is to multiply through by the LCM. The LCM, of course, is s plus 1 to s plus 2. So if you multiply through by that, you have 2s plus 3 equals a into s plus 2, because s plus 1 times s plus 2 multiplied by s plus 1 cancels out. So you have s plus 2 left. Then here you have b into s plus 1. And then we have what we call the cover-up method. We are looking for a and b. So using this is a very simple situation where we can easily use the cover-up method. And the cover-up method simply means find a way of eliminating each of the terms. And the cool way to go is if you want to eliminate A, for instance, or let's start by eliminating B. If you want to eliminate B, for instance, if you can set this thing to 0, if you can say s plus 1 equals 0, then you can easily make B 0. And that means that s is equal to minus 1. So it means that if s is equal to minus 1, you can eliminate B and then you get A. Okay? So we can say set s equals minus 1. So anywhere you see s, make it minus 1. That's what that means. So you have 2 into minus 1 plus 3 equals a into minus 1 plus 2 plus b, okay, into minus 1 plus 1. Minus 1 plus 1 is 0. So b times 0 is gone. So we have 2 times minus 1. We have minus 2 plus 3 equals a into minus 1 plus 2. Okay. So minus 2 plus 3 is 1. Then a into minus 1 plus 2 is also 1. So a is simply 1. Easy peasy. So a is 1. We have that. So the next thing we want to do is find b. So we can use cover-up method also to do that. If you want to eliminate A, right? If you want to eliminate A, then do cover up for this one too. Set this one to 0. And that means that s will be minus 2. So we just say set s to be minus 2. So if s is minus 2, what do we have? That'll be 2 into minus 2 plus 3 equals a into minus 2 plus 2 minus 2 plus 2 plus b into minus 2 plus 1. So 2 into minus 2 is minus 4 plus 3 equals a into minus 2 plus 2 is 0. Then b into minus 2 plus 1 is minus 1. So this is gone. So we have minus 1 here equals minus b. Okay. So that simply means that b is equal to 1. Okay. So we just see now that therefore a is equal to 1 and b is also also equal to 1. So we can then go ahead to say that uh so f of s, which is 2s plus 3 all over s plus 1, s plus 2, is the same as 1 over s plus 1 plus 1 all over s plus 2. And with this kind of thing now, we can go for the inverse Laplace. So the next step is to take the inverse Laplace transform. Take the inverse Laplace transform. Okay. So that means that we have Laplace inverse of f of s. Okay. And that is simply f of t. And that will be equal to the Laplace inverse. So we have the Laplace inverse of 1 over s plus 1. Of course, you know it is distributive Laplace inverse. So Laplace inverse again of 1 over s plus 2. Okay. And of course, we know what in the time domain will give you 1 over s plus 1. Easily, you remember that the Laplace of e raised to power minus at will simply give you 1 over s plus a. Okay, so if you have s plus 1 now, what that simply means is that 1 over s plus 1 is the same thing as e raised to power. A here now is 1, so e raised to power minus 1t, okay, then plus e raised to power minus 2t, and that is what that tells us. Okay, so we say f of t now in the time domain is e raised to power minus t plus e raised to power minus 2t. So that's the easy way to handle that. Okay, so that's straight to the point. Before we go, let's take some practice questions. Let's take some practice questions. Okay, practice. Find the inverse Laplace transform of the following using partial fraction decomposition, right? So number 1, you have f of s equals s plus 2 all over s plus 1, s plus 3. Okay. Number 2, f of s is equal to 3s plus 5 all over s plus 2 into s plus 4. Then finally, number 3, f of s equals 2 all over s into s plus 3. Okay, so use Laplace, find the inverse Laplace of these ones using partial fraction decomposition. Thank you for listening. Let me see your answers in the comment section, either on Facebook or on YouTube. And of course, if you have topics you'd like me to treat or problems you'd like me to solve, feel free to also drop them there. And Let me also know how helpful these videos are for you. If you have not subscribed to this channel, you know you are missing a lot already because there's a lot on the channel already, and there's still a lot more coming. So you don't want to miss out on any of that. And for those who have subscribed and everyone who's just going to subscribe now, don't forget to hit the notification bell so you can always get alerted each time a new video is released. And lastly, be sure to like and share so that more people, and of course, make a comment so that more and more people can have access to this great content. I mean, a lot of people have found it very useful. And you want more people, you have family members, friends, and all those people to take advantage of this great learning going on here. Till I come your way again, keep doing maths right. Bye.